This video is the next in our series about solving different types of equations. And in this lesson, we're going to be talking about solving rational equations. So you'll notice I pulled two examples from homework here. Both of them are from homework 1, problem 14 and problem 18. And the first question that might come to mind is, well, what makes these rational equations? And the answer to that is the presence of a rational expression. So in the case of the first problem, we have 16 over z plus 2, and that is a rational expression. Once your equation has a single rational expression in it, we call it a rational equation. And 16 over z plus 2 is called a rational expression because it is an expression that has a denominator that contains a variable. Looking ahead to example 2, you'll actually notice that we have two rational expressions present. We have x over 2x plus 3 and x minus 3 over x plus 2. So it's totally fine to have two totally different rational expressions in your equation. As long as there is one, it's called a rational equation. So before we go into kind of the details of solving these two problems, let's talk about the idea that we're going to be really adhering to when we're solving rational equations. And that idea is almost identical to the idea that we use when solving equations with fractions. Namely, we clear the denominators. And as I'm writing that, maybe you could think to yourself, well, how did we do that when we had equations with fractions? And what I hope you'll remember is that we achieved that by multiplying both sides by the least common multiple, aka the LCM, of all of the denominators present. So in a problem like the first example we have here, where you only have one denominator to speak of, that's pretty great because we just multiply both sides by z plus 2 and we're off to the races. However, the thing we didn't have to worry about with equations with fractions is denominators not being constant. With a fraction, the denominator is a number, and it's perfectly harmless to multiply both sides of an equation by a number. But here the denominators are variable. So this is where I have to remind you of something that we actually talked about in our very first video. And that's the multiplication property of equality. And the multiplication property of equality essentially says you can multiply both sides of an equation by anything you want except for 0. So it looks something like this. If A is equal to B and C is not equal to 0, then A times C is also equal to B times C. But it says very clearly there that C cannot be 0. The reason for this is simple. If you have two quantities and you're trying to figure out if and when they're equal, and then you go and multiply both of them by 0, regardless of what they were, they are both going to become 0. So multiplying both sides by 0 completely annihilates any information you had in your original problem. So you have to be very careful when multiplying both sides of an equation that you're not multiplying by 0. So we're going to have to be very careful with this when we're solving equations in these two examples. So let's go ahead and start. And let's see how this pans out. So I'm going to go ahead and recopy this problem here, just so we have plenty of space. And like I said before, since we only have one denominator to worry about, we're going to go ahead and multiply both sides by it. And I'm going to preemptively do something. I'm going to say, you know what? I'm multiplying both sides by z plus 2. And according to the multiplication property of equality, I cannot be multiplying both sides by 0. So I'm going to say off to the side here z plus 2 cannot be 0. So z cannot be negative 2. I don't know what's going to happen here yet. I haven't walked through the process. But if at the end of the whole cleanup solving process, I end up with negative 2 as a possible solution, I go back to this and I say, nope, negative 2 is excluded because when z is negative 2, I'm multiplying both sides by 0, which is not, that's not possible. All right, so let's see what happens. So again, if negative 2 turns out to be a possible solution, we have to kick it out. All right, so we're going to distribute here. Distributive property never sleeps. So we have z times z plus 2. Nothing reduces in that first product. The second product, the z plus 2's reduce. So we're just left with 16. And then on the right, there's nothing to reduce with. So we just distribute through. Let's open up the parentheses here on the left. Like that. So we have z squared plus 2z plus 16 is equal to 6z plus 12. Let's notice that this is a quadratic equation. And the last couple of lessons, we were talking about solving quadratics. So what we're going to go ahead and do is we're going to set one side to 0. It's probably easier to move everything on the right-hand side over because there's less stuff on the right-hand side. And then I'm going to continue on here to finish. So that leaves me with z squared minus 4z plus 4 is equal to 0. So here, this actually turns out to factor, and it factors into z minus 2 times z minus 2, or you can also write z minus 2 squared. And this is where we have the zero product property that we're going to apply here. I'm going to write for short ZPP, which is the zero product property that we introduced a couple of lessons ago, telling us that if two things multiply to 0, one of them has to be 0. Here the two things are the same, so they essentially both have to be 0. So Z has to be 2. Now notice, 2 is not in my restricted list. Negative 2 is, so we came close, but 2 is not. So in fact, this equation has a solution, and that solution is 2. All right, now on to our next example. So here you have two different denominators. I'm not going to say too much about this, but essentially the two denominators are both linear. Neither of them can be factored any further, which means that the thing by which we're going to multiply both sides is just going to be the product of the two denominators. You have one problem in homework 1 that I will let you all get to and kind of noodle on, where the denominators factor and the least common multiple is actually like a combination of those factors, not just the product of all the denominators. But I'll let you get to that problem. We can talk about it in discussion. You can ask me about it in office hours. I'd like to give you a chance to noodle on it and puzzle over it. But here, that's not an issue. So again, I'm going to copy this problem over to have plenty of space. And I'm going to multiply both sides by 2x plus 3 times x plus 2. And as I'm doing this, once again, I'm thinking, okay, but I got to make sure that I'm not multiplying both sides by 0. So off to the side here for myself, I'm going to say 2x plus 3 times x plus 2 cannot be 0. Once again, I'm going to use the zero product property to say that if two things multiply to 0, either the one or the other has to be 0. And I'm not going to walk through all the steps, so I encourage you to do that on your own time and then ask questions if it's confusing. But we're going to set 2x plus 3 to 0, and we're going to see that x cannot be negative 3 halves. And we're going to set x plus 2 to 0 and see that x cannot be negative 2. So these are our restricted values. I mentioned the term before, but I want to actually write it this time. These are our restricted values, meaning that if at the end of our solution we come to see that, oh, negative 3/2 wants to be a solution, nope, we got to kick it out. All right, so here we go. So we're going to distribute, clean up, so on and so forth. Okay. So on the left, the first product, the 2x plus 3's cancel, leaving us with x times x plus 2. In the second product, the x plus 2's cancel, leaving us with x plus 3 times 2x plus 3. And then on the right-hand side, nothing cancels. So we're just going to have to distribute all the way there. Okay, so here we go. We're going to open up parentheses and combine like terms. So we have x squared plus 2x. Now watch carefully here, because here we have a minus sign. So that minus would need to distribute through the entire product that we're about to perform. So watch. X times 2x is 2x squared. So we have minus 2x squared. Okay. Then we have x times 3 is 3x. 3 times 2x is 6x. Add those, we get 9x. So it's minus 9x. And then 3 times 3 is 9. So minus 9. Okay. On the right, we have 2x squared plus 4x plus 3x. So that's plus 7x. Plus 6. By the way, if you're watching me do these sorts of computations and you want to kind of pause the video and do them out for yourself to make sure that you're following along, I think that's a great idea. I highly encourage it. Okay, let's combine like terms on the left-hand side. So we have negative x squared minus 7x minus 9 is equal to 2x squared plus 7x plus 6. Okay. And now we're going to go ahead. This is another quadratic equation. I'm not going to write it this time, but we're going to go ahead and move everything over. So here, I'm going to move everything that's on the left side over to the right. And I'll tell you why. I'm doing this because there's a lot of negatives on the left-hand side, and if I try to move the right-hand side over, those negatives are just going to get bigger. So by moving the left to the right, I'm actually able to turn my negatives into positives, which makes work a lot easier. So I'm going to add x squared, add 7x, and add 9 to both sides. Okay, so I have 3x squared plus 14x plus 15 is equal to 0. Okay? So again, this is a quadratic equation. You could use the method of the quadratic formula here if you want. I'm actually going to go ahead and factor. And the reason I'm going to factor is fairly simple. Because I have 3x squared, I know that it'll be 3x and x. And I actually have a pretty good feeling that this ends up factoring. Of course, you are welcome 100% to explore that and play with it and see how it works out for you. Okay, so if I do 3x, 15, it's going to have to be 5 times 3. Yes, it could also be 15 times 1, but the numbers that you get with 15 times 1 are big, and they're not going to work out for what we want to have happen here. So it's going to have to be 3x plus 5 times x plus 3, because as we discussed before, the 3 cannot live over with the 3x. Then there would be a greatest common factor, which I did not have to start with. So again, play with this on your own, pause the video if you need to, bring questions if you have them. So 3x plus 5 times x plus 3 is equal to 0. So using the zero product property, I'll mark that here one more time. We either set 3x plus 5 to 0, which gives us a solution negative 5/3, or we set x plus 3 to 0, which gives us a solution negative 3. Hold on just a second. Let's go up to our restricted values. They are negative 3/2 and negative 2. So both of these are fine. So those are, in fact, our solutions. So the second equation has two solutions, and the first one has just one. So to really quickly recap, we are taking these rational equations, we are multiplying both sides by the least common multiple of their denominators. We first make sure that we restrict the values that would make those denominators be 0. And then we distribute, we solve, and we find the solutions. In the end, we circle back to make sure that none of our solutions were in the restricted values, and if they are, we kick them out. That's it for our little mini lesson on solving rational equations. Pause, rewind, and rewatch as often as you need to. See you later. Bye.